Alright, what we have here, this looks like number one off the homework from last night. This is three equations, three unknowns. And our goal is to really solve this system of equations for values of x, y, and z such that those values satisfy all three of those equations simultaneously. To do this, we can use either elimination or substitution. Really, it depends on the type of problem. So if you notice, if you look at this problem, if we look at equation number 2 and equation number 3, notice how we have values for the y of a 5y here and a negative 5y here. We can go ahead and just add those two equations, and notice we get negative 4x. You know, the y's cancel out, and we have minus 2z is going to equal 14. So that one was pretty easy because you already had the 5 y's that had canceled out. Now, if we look at the top two equations, we want to eliminate the y in the top two equations as well. Okay, so let's see what we got here. Let's multiply this top one by negative 5. Let's multiply this middle equation by 3. Let's see what we come up with here. Alright, so I'm going to move over here to the right so we get negative 20x minus 15y, and then we get plus 10z, and that's going to equal negative 25. So again, this first equation, which is here, multiplied the whole thing by negative 5. Alright, the second equation, that's multiplied by 3. Alright, that'll give us 6x, and then we're going to have plus 15y plus 3z, and that's going to equal 54. Okay, so again, we multiplied the top equation by negative 5, which is here, the second equation by 3, and it yielded two new equations here to the right. So let's go ahead and add these together. So now we're going to get negative 14x. If you notice, the y's cancel out. We have plus 13z, and that's going to equal, looks like 29. Alright, so now what we've done is we've effectively reduced, I'm going to erase these little marks right here. What we've done so far is we've basically erased or eliminated, let me move this down here so we can clearly see. So this will be negative 14x plus 13z equals 29. So what I was saying is we basically took an equation that contained x, y, and z, and we reduced it to these two equations, which just contain x and z. Now this one, let's see what we can do with this one. This one's not too pretty. Let's multiply this first equation by, let's go with 7. Let's multiply this top equation by 7. Let's multiply this bottom equation here by a negative 2 and see what we come up with. Alright, so I'm over to the right here. I'm going to have negative 28x minus 14z. Of course, that's going to equal, looks like 98. Alright, so that's this equation heading this way. Second equation, I'm going to get 28 when I multiply by a negative 2, and this will be minus 26z. This is going to equal, it's going to be a negative 58. So now effectively we've created these new equations that we can again add together. Let me go down here and change colors. Alright, so if we go ahead and add these together, naturally the x's cancel out. Now we have negative 40z is equal to 40. So in this case, z is equal to negative 1. So I'm going to get on here, and now this is what we call an ordered triple instead of an ordered pair. And now we know that z is equal to negative 1. Alright. Now, we can take this negative 1 and we can transplant it back into this equation for z, And of course, we're going to plug in a negative 1 in here, getting kind of crowded. But basically, if you see right here, 14, and then this positive 2 comes over and becomes a 12. So 14 minus 2 becomes 12. And then if you notice, negative 4 goes into 12. If you notice up in here, that'll be negative 3. So now we know x is equal to negative 3. All right. Let me erase this so we have a little bit of room. So now we have values for, let me change colors here so we can get a little contrast. Now if you notice, we have values down here for x. We have values for z. All we're missing is y here. And how we do that is we're going to go to this equation. We're going to plug back in values for x and z. So to do that, this becomes negative 3 in here, and then negative 1 in here. So if I do this real quick, this becomes 18, and this becomes 3. So 18 and 3 becomes 21. Bring it to the other side, becomes negative 25. I know this is getting cramped, but I think you guys can see. So now we have negative 5y equals negative 25. And of course, y in this case is going to be equal to 5. And there you go. That's going to be y. So that's it. That's our ordered triple, negative 3, negative 3, 5, and negative 1. And remember, you can always check these by plugging them into all three of the original equations. All right. Thanks a lot. And if you have any questions, please ask, and have a great day.